Okay, so today we're talking about the fundamental theorem of algebra. And you'd think if it was so fundamental, it would be introduced before 5.6 in Algebra 2. So maybe it's not that fundamental, but anyway, this is something we've been talking about really all unit, especially in 6.3 when we talked about solving those polynomial equations by factoring. We talked about the fact that whatever the degree of our polynomial was, that was how many solutions we needed, how many roots we needed for that equation. So that's basically what the fundamental theorem of algebra says, that if p of x is a polynomial of nth degree, then the equation p of x equals 0 has exactly n roots. Some of them might have multiplicity and some might be imaginary, but every polynomial equation of nth degree has n roots. And we saw that in the quadratics unit, where some of the quadratic functions had two real zeros, like this one. If we factored x squared minus 4, that factors to x plus 2, x minus 2, and so our zeros are negative 2 and 2. We had cases where we just had 1 0, but it occurred more than once. For example, if we were to factor x squared minus 2x plus 1, factors of 1 that add up to negative 2 are, sorry about that, are negative 1 and negative 1. So that occurs twice. So our 0 of 1 has multiplicity 2. And in this case, there are no x-intercepts, so the zeros aren't real. So in this case, we have two imaginary zeros. If we were to solve this, setting this equal to 0, and then solving it by completing the square, by moving the 2 over by subtracting it first, and then completing the square by adding 1. So then when we factor this, we've got x plus 1 squared equals negative 1. Taking the square root, x plus 1 equals plus or minus I. So our two zeros are negative 1 plus I and negative 1 minus I. So those are our two zeros for that one, and they're both imaginary. So we're going to expand this today. The first one is we're going to solve a couple of equations with these roots, and we are going to first find the rational roots of these equations, and then using our graphing calculators, and then use synthetic division to knock it down to find the the irrational roots, or the non-real roots, if there are some of those. So the first thing we're going to do, and we're going to go back and forth between the calculator, so I'll have to adjust my screen here so I can use the keypad to find this, or use a keypad to do this. I'm going to take this polynomial and put this into y equals on my calculator. So I'm going to go on my calculator and clear out what's there, and I'm going to put this polynomial. So I may have to go back and forth here because my memory is awful because I'm old. So we've got x to the 5th minus x to the 4th minus 3x cubed to start with. So x to the 5th, and then right arrow to get out of the exponent, minus x to the 4th, right arrow, minus 3x cubed. And that's as much as I can remember, so I'm going to just sneak a peek back at the plus 3x squared minus 4x plus 4. So plus 3x squared minus 4x plus 4. And I'm just going to graph this on the standard window, so zoom 6. And my calculator is thinking, so there is that. I mean, if you wanted to see this other maximum here, we sure could adjust the window, and maybe looks like moving that up to 20 would be enough, the y max, and then graphing that. If you felt so inclined to see that maximum. Okay, so here we have it. We see we have 3 zeros. It looks like it's at -2, 1, and 2. It would surely be okay to just confirm that by actually calculating that. Oh, I went plenty far there. And then to the right of that, so that first one is in fact at -2. So I'm going to go ahead and down here at the bottom, I'm going to write these rational zeros that we have. Okay, so then we have -2. Okay. So I'm going to just make sure and calculate that second one. I'm going to calculate another 0. I'm to the left of it, so that's good. And I'm going to right arrow until I go to the right of it. Sounds good. And that is in fact 1. So I'm going to go ahead and write 1 down here because I'm finding all the roots of this equation. So then I'm going to go back to my calculator and just confirm that that second one is 2. It looks like it is 2, but just doesn't hurt to make sure. So we'll go ahead, move it a little bit to the right, hit enter for the left bound, and then move it until I'm to the right of that x-intercept. And it is in fact 2. So we used a calculator to find 3 of them, and those are the only 3 that we see. Doesn't matter how far out you go, those are the only 3 that you will see. So then what we're going to do next is we are going to do a series of synthetic divisions so that we can knock this 5th degree polynomial down to a quadratic. So we're going to use these roots we found, and we're going to use synthetic division. So we're going to start with -2 with the synthetic division, and in a second I'm just going to write the coefficients of that polynomial. So 1, -1, -3, 3, -4, and 4. Okay? And with the synthetic division, don't forget that this is our remainder, and we should end up with 0 there. So let's just see what we have. Again, we bring down the 1, multiply to get -2, add these together to get -3, multiply -2 times -3 to get 6, add these together to get +3, -2 times 3 is -6, add these together, -3, 6, 2, -2 times 2 is -4, and we do in fact get 0. So now what we've now knocked this down to is constant linear quadratic cubic quartic. We're now down to a quartic, or a 4th degree polynomial. So then we're going to move to the next 0, the 1, and perform synthetic division to that. And here our remainder is going to be underneath the constant. Again, hopefully we end up with a remainder of 0 there. So I'm going to go ahead and, well, let's go back to blue. Alright, so bring down the 1, multiply, we get 1, add them together to get negative 2. 1 times negative 2 is negative 2. Add these two together to get 1. 1 times 1 is 1. Negative 2. 1 times negative 2 is negative 2. And in fact, remainder is 0. Now what we've knocked this down to is a cubic. Constant, linear, quadratic, cubic. And so we're going to take our last rational 0, 2, and we're going to perform synthetic division to that. And our remainder should be under here. Hopefully we'll end up with a remainder of 0. So bring down the 1, 2, 0, 2 times 0 is 0, add to get 1, 2, and in fact 0. So what we've done is we've knocked this down now to a quadratic that we can solve when we set this equal to 0. Okay? Because what we've essentially done is we've knocked this down to a product of factors. What we've done is we've taken this quintic and knocked it down to factors of x plus 2 times x minus 1 times x minus 2 times x squared plus 1. And we're setting each of those equal to 0, so we're setting that piece equal to 0 as well. And solving this for x, that's equal to negative 1, so x is plus or minus I. So the last two roots of this equation, of which we should have 5 by the fundamental theorem of algebra, are positive I and negative I. And there are our 5 roots for that equation. In B, we should have 4 roots. Now, one of them will happen. First thing we do is set this equal to 0. So we're subtracting the 13x squared and adding 10x. Kind of telling tales out of school here, but I started this problem earlier and I screwed up majorly. When I tried to graph this, I didn't get rational zeros, and that was because I had minus 10x here instead of positive 10x. So that was embarrassing. So I started recording all over again because I just couldn't admit to that. Wait, I just did. Anyway, so the first thing we can do is we can factor out an x, and that we're left with then x cubed plus 2x squared minus 13x plus 10. Now, the fact that we have this x here, that means that one of our roots is 0. Okay? So now what I'm going to do is go to the calculator and put this remaining polynomial, that cubic, into the calculator. And now hopefully this time I get rational roots. So let's keep our fingers crossed. So I'm going to x that out. And so going back, x cubed plus 2x squared. That's probably all I can remember anyway. So I'll just plus 2x squared, and just to go back to confirm, minus 13x plus 10. So minus 13x plus 10. So now I'm going to go back and graph this on the standard window just to see what we have left. Okay, so we actually have 3 there. So if we want to find those, we certainly can. Looks like this one might be at -5, and then looks like we might have 1 and 2. These two might be irrational. Well, we can check. Maybe we might find them all, and we don't need to do any synthetic division here to knock it down to a quadratic. So still going, still going, still going. Still going up. Oh, now it's starting to come back down. Taking a drink of water while I do all that pressing of the arrow keys. So we have another 0 of -5. Okay, so then we'll see if those other ones are actually rational yet. So looks like it could be 1. We can confirm calculating that 0. It is 1, so we can just go ahead and put 1 there. And that last one, I'm guessing, might be 2. We can confirm that with the calculator. No sense doing any synthetic division if we don't have to. Not what I wanted to do. Got a little excited there because we didn't have to do any synthetic division. Let's go ahead and move that to the right bound. So yeah, our last 0 is 2. Since we had started with a quartic, we have our 4 roots. So we're good. Okay. In the next video, we will talk about how to find zeros of functions. We'll translate this to functions.